More than 7 Russian tanks and armored vehicles, worth around $12 million in total, were knocked out in one failed assault. A Russian mechanized formation can enter the battle with tanks in front, APCs behind them, and infantry waiting for the moment to move closer to Ukrainian defensive positions. From the ground, the assault may still look alive. But from above, a Ukrainian reconnaissance UAV may have already seen the direction of movement, measured the rhythm of the advance, and waited for the formation to reach its weakest moment. When the lead vehicle is locked down, the vehicles behind it lose rhythm. The road becomes narrower. The spacing inside the formation begins to break down. And every second of delay gives Ukrainian FPV teams, bomber drones, mines, and artillery more time to turn Russian movement into a weakness. This is not just a story about one tank being hit. It is a warning about how Ukraine is using drones as a first defensive layer to break Russian mechanized assaults before they can reach infantry positions. So why can one blocked vehicle put an entire attacking formation in danger? Why do drones not only destroy armored vehicles, but also break the rhythm of Russia's advance? And what does this reveal about how dangerously the future of mechanized warfare in Ukraine is changing? Let's find out with military force. Ukraine is turning attack drones into the first barrier against Russian armored assaults, and this changes where the battle begins. In older mechanized warfare, a tank column often reached the edge of a defensive position before the decisive fight started. In Ukraine, that moment can arrive earlier because a reconnaissance UAV may detect the formation while it is still moving toward the front line. The key point is not that drones replace trenches, mines, or infantry fire. The key point is that they push the danger zone farther forward. A Russian assault may still be built around tanks, APCs, and infantry carriers. But once those vehicles appear under Ukrainian observation, they are no longer moving freely. Their route can be watched, their spacing measured, and their speed judged before they come close enough to threaten Ukrainian infantry. This gives Ukrainian defenders something valuable: time. If a reconnaissance UAV detects the formation early, FPV teams do not have to wait until the vehicles are firing into infantry positions. They can strike while the assault is still in the approach phase, before Russian armor can fully use shock, protection, and momentum. A kamikaze drone does not always need to destroy a tank on the first hit to change the battle. It can strike the lead vehicle, damage a track, hit the engine area, or force the driver to slow down. Once that happens, the formation behind it begins to lose order. Vehicles meant to move as one group start reacting as separate targets. Some slow down. Others shift position. The entire assault becomes easier for Ukrainian operators to follow from above, because the pattern of movement is no longer clean. This is why drones now function as a mobile defensive screen. They can meet the assault before it reaches the trench line, and they can force Russian crews to make decisions under pressure. Every second of confusion matters, because armored attacks depend on timing. If the first vehicle hesitates, the vehicles behind it must adjust. If the route is watched from above, that adjustment can become the next mistake. For Ukrainian infantry, this drone layer can reduce the pressure at the most dangerous moment. Instead of waiting for tanks and APCs to arrive at close range, defenders can disrupt the assault earlier and shape the battlefield before direct contact. The assault may still be moving, but its freedom is shrinking, and its next mistake becomes easier to predict. That is where the next danger begins. When drones become the first defensive layer, the most important Russian vehicle in the assault also becomes the first target, the machine sent forward to open a path through the minefield. Russia still needs mine-clearing tanks and armored vehicles because minefields can stop a mechanized assault before it truly begins. A column cannot rush through a defended approach if the ground ahead may be seeded with explosives. Without a cleared lane, the vehicles behind the lead machine may be forced to stop, bunch together, or search for another route under Ukrainian observation. That is why the vehicle sent forward with a mine-clearing system becomes one of the most important machines in the assault. But that same role also makes it easy to identify. The lead vehicle must move first, and it must stay on the route that the rest of the formation is expected to follow. For Ukrainian reconnaissance drones, this creates a clear signal. The machine at the front is not just another tank. It is the key to the path. Once a Ukrainian UAV sees that vehicle, the defenders can understand more than the position of one target. They can read the likely direction of the assault, the crossing point through the minefield, and the strip of ground Russia wants to use as its main approach. This is why early detection matters so much. It gives Ukraine a chance to attack the structure of the assault, not only the armor of one machine. At this point, the fight becomes a contest over timing. Russia wants the lead vehicle to open the lane quickly and keep the formation moving. Ukraine wants to interrupt that process before the rest of the column can pass through. If FPV teams or bomber drone crews strike the lead machine at the right moment, the result can be larger than a single damaged tank. The first effect of stopping the lead vehicle is confusion. The vehicles behind it cannot continue as planned because the route ahead is no longer certain. Some crews may slow down. Others may try to steer around the blocked machine. A few may keep moving too close together because the assault plan was built around speed. In that moment, the formation starts to lose its original shape. This is where the danger grows. A mechanized assault needs rhythm to create shock. Tanks and APCs are most dangerous when they move with pressure, spacing, and a clear direction. If that rhythm breaks, the force becomes easier to study from above. Ukrainian UAV crews can keep watching the same route, while drone operators prepare the next strike against the next exposed vehicle. A stopped lead machine also creates a physical problem on the ground. It can block the cleared lane, narrow the road, or force the vehicles behind it toward ground that has not been checked. That is when a column can be pushed toward mine traps without anyone on the ground having a full picture of the danger. From inside an armored vehicle, the crew may see smoke, dust, and the machine ahead. From above, a UAV can see the entire pattern. The real loss, then, is not only the vehicle itself. The deeper loss is tempo. Once tempo disappears, the assault loses its ability to surprise Ukrainian infantry or overwhelm a position with a sudden armored push. Every delay gives Ukrainian defenders more time to observe, choose targets, and prepare follow-up attacks. The lead vehicle was supposed to open the way, but once it is stopped, it can turn the route into a trap that grows more dangerous with each delayed movement behind it and every uncertain decision made under pressure. That broken rhythm sets up the next stage of the battle. After Ukraine identifies the lead vehicle and disrupts the assault, the next task is often to make Russian armor lose mobility before destroying it completely. Ukraine's common method is to stop Russian armor first and destroy it later, because a moving vehicle is still part of an assault, while a trapped vehicle becomes part of the battlefield. A tank, APC, or IFV can survive a first hit and remain dangerous if it keeps moving. But once it loses a track, wheel, or engine power, its value changes. It can no longer choose the route, avoid danger, or support vehicles behind it. This is why mines and drones often work as tools of paralysis before destruction. A mine under the track can freeze the lead machine in place. An FPV strike into the rear engine area can slow the vehicle enough to break its roll. A hit near the turret base can start a fire that forces crew to react before the assault reaches its objective. Once a Russian vehicle is immobilized, it loses the most important defense it had: movement. Armor can protect against fragments and hits, but it cannot hide a vehicle fixed in one place under a UAV. Open ground becomes dangerous because there is no cover. A road becomes dangerous because the direction is clear. A tree line becomes dangerous because the vehicle may be hidden from the side, but not from the sky. A disabled machine also changes the behavior of the crews around it. Other vehicles may hesitate, and soldiers may look for another path or wait for instructions. This reaction creates visible movement for Ukrainian drone teams. The vehicle that first appeared as a protected machine now becomes a marker on the ground, showing where the assault has slowed and where the next strike may be needed. FPV drones are most effective when operators aim at the parts of the vehicle that can cause wider failure. A strike on the track can stop a tank without destroying the turret. A hit on the engine deck can create smoke, heat, and panic inside the crew compartment. A drone guided toward an open hatch can turn a damaged vehicle into a burning loss. This is why the first hit is often only the beginning. Some armored targets do not burn immediately. Others keep their shape after impact and may look recoverable from a distance. But if a reconnaissance UAV continues to watch, Ukraine can bring in another FPV, a bomber drone, or a grenade drop. Each follow-up attack tests a new weak point until the vehicle is no longer worth saving. When Russian crews abandon a damaged vehicle, the battlefield does not become safe. A tank or APC left behind can be recovered later, repaired, stripped for parts, or used again if the area changes hands. For that reason, Ukraine often continues striking vehicles after the crew has left. The aim is not spectacle. The aim is to make recovery impossible. A burning vehicle also creates a wider effect on the assault. It blocks space, produces smoke, and warns other crews that the route is being watched. If ammunition remains inside, even a delayed fire can become decisive. Flames that begin in one compartment can spread toward stored rounds or fuel, turning a damaged machine into a total loss. That is why immobilization is only the first stage. To turn a stopped vehicle into a confirmed loss, Ukraine needs observation, timing, repeated pressure, and enough drones to maintain attacks. This tactic works best when drones, mines, and fire support are parts of one connected kill chain. Ukraine's drone defense becomes most dangerous when each tool supports the next one. A reconnaissance UAV does not have to destroy anything by itself. Its first job is to find the Russian column, hold it in view, and turn movement on the ground into usable information. Once that happens, the assault is no longer just a line of vehicles. It becomes targets with direction, speed, spacing, and weak points. This is the center of the kill chain. The reconnaissance UAV watches from above, while Ukrainian crews decide which weapon should act next. If the column is moving fast, artillery may disturb the formation. If one vehicle slows down, an FPV team can strike with precision. If a vehicle is trapped, a bomber drone can finish the target from above. The value is not only in the hit itself, but in the constant observation that keeps the target under pressure. Artillery becomes more effective inside this system because it is no longer firing blindly at a general area. When a UAV tracks a column, artillery crews can adjust fire against real movement. A shell or cluster strike does not need to destroy every vehicle. It can force crews to slow down, widen spacing, change direction, or leave the road. FPV drones then serve as the precise strike element. They are most useful when the target is moving slowly, trapped in a narrow route, or already damaged. A skilled operator can guide the drone toward a vulnerable angle instead of wasting the strike on the strongest armor. This makes each drone more than a small explosive device. It becomes a guided decision against a specific weakness. Bomber drones play a different role. They are useful when the target is no longer moving quickly. A tank with an open hatch, an APC stopped near a tree line, or a damaged vehicle left on a road can be attacked from above. Their value is patience. They can wait for a safer angle, then drop a munition into a place where armor offers less protection. Mines are also part of the chain, not just obstacles on the ground. A mine under a track can stop the lead vehicle and block the path behind it. That blast creates the pause that UAV crews need to keep watching, artillery crews need to adjust, and FPV teams need to attack the next exposed machine. This is why Ukraine's system is more powerful than any single drone. Reconnaissance finds the target. Mines and artillery break the movement. FPV drones strike the exposed weak point. Bomber drones finish what remains. Together, they turn speed into exposure and pressure into disorder. The assault is not defeated by one tool alone, but by the way each tool hands the target to the next. The deeper effect is psychological as well as tactical. Russian crews do not only face the weapon that hits them, they face the knowledge that every movement may already be watched, and every pause may invite another strike. Once that fear enters the formation, decisions become slower and spacing becomes harder to control. But this system does not operate in an empty sky. Russia uses electronic warfare, armor protection, and battlefield deception, which means Ukraine must keep adapting the way it guides, times, and delivers each strike. Russian electronic warfare remains one of the hardest problems for Ukrainian drone teams because it attacks the link between the pilot and the drone. An FPV drone may be close to the target, but if the signal weakens at the final moment, the strike can lose accuracy. The drone can drift, miss the angle, or crash before impact. In some cases, the operator may have to abandon the first approach and search for a safer way in. This makes the battlefield more complex than a simple contest between cheap drones and expensive armor. Russian forces use jammers to protect vehicles, strong points, and routes expected to face drone pressure. These systems cannot protect every target all the time, but they can make each strike harder. For Ukraine, the answer is not only to launch more drones. The answer is to adapt the method of attack, because each failed approach gives Russian crews more time to hide. One important adaptation is the use of fiber optic FPV drones. Because the control link travels through a physical cable instead of a normal radio signal, this type of drone can reduce jamming. It is not perfect, and it has limits in range, movement, and handling. Still, in areas where electronic warfare is dense, it gives Ukrainian operators another way to keep control during the final approach. Ukraine also uses simpler methods when the situation demands it. A Mavic or bomber drone can hover above a damaged or abandoned vehicle and drop a grenade from a safer angle. This approach is slower than an FPV strike, but it can be useful when a target has stopped moving or when its hatch is open. In that situation, patience can be more valuable than speed. Operator skill becomes the deciding factor. A good pilot must read the target, terrain, and interference at the same time. Sometimes the best option is a low approach against the rear of the vehicle. Sometimes it is better to climb, wait, and drop from above. Sometimes the drone must avoid the strongest armor and search for a gap around added protection. That is why weak points matter. The hatch, rear engine deck, turret base, and gaps around explosive reactive armor may be more important than the thickest part of the tank. A direct hit against strong frontal armor may waste the drone. A precise hit into a weaker area can create smoke, fire, or internal damage that changes the outcome. Electronic warfare does not remove drones from the battlefield. It forces Ukraine to use them with discipline. Reconnaissance must keep watching. FPV teams must choose angles carefully. Bomber drones must wait for the right moment. Artillery must stay connected to the same picture. Under that pressure, the battle becomes less about one dramatic strike and more about control, patience, and timing. When Ukraine maintains observation, enough drones, and skilled operators, even modern Russian armor can become vulnerable if it remains in view too long. Even modern Russian armor such as the T-90M is no longer safe once it stays under Ukrainian observation for too long. A tank can survive the first hit and still appear recoverable from a distance. But if drones continue to track it, the danger does not end. A second strike can force it to lose control. A third can start a fire. Another hit can reach ammunition, fuel, or weaker internal areas. This does not mean tanks have become useless. Armor still matters when it moves with speed, cover, infantry support, smoke, electronic warfare, and recovery teams. The problem is that every protection becomes weaker when a vehicle is isolated and watched from above. A modern tank is built to survive impacts, but it is not built to sit exposed while drone crews test one weak point after another. That is why the T-90M matters as a symbol. It shows that modernization alone cannot solve the battlefield problem. Better armor can help. Extra protection can delay destruction. But if the vehicle loses movement and remains visible, the battle becomes a test of time. The longer it stays in view, the more chances operators have to find the angle that works. Ukraine is pushing drones beyond the front line. The same logic reaches ammunition depots, command posts, communication centers, radar systems, air defense launchers, logistics hubs, and drone support sites behind Russian lines. These targets may not be as dramatic as a burning tank, but they shape the battle before the next assault begins. A Russian push needs more than vehicles. It needs fuel, ammunition, radio links, air defense, and command posts to direct the attack. If drones hit those systems in the rear, the pressure appears later at the front. The column may arrive with fewer supplies, weaker protection, slower orders, or less support. This is why drones have become central to modern warfare in Ukraine. They do not replace infantry, tanks, or artillery. Infantry still holds ground. Tanks still provide shock. Artillery still delivers heavy fire. But drones now help find targets, guide strikes, confirm results, and lower the cost of damaging expensive Russian equipment. From the front line to the rear, drones are changing more than how a tank is destroyed. They are changing how an assault is prepared, detected, and broken. Mechanized warfare has not disappeared from Ukraine, but its survival rules have changed. Tanks, APCs, and armored assaults still matter because Russia needs armor to move infantry, pressure defenses, cross dangerous ground, and search for weak points in Ukrainian lines. Yet every armored push now enters a battlefield watched from above, where mines, artillery, FPV drones, bomber drones, and electronic warfare shape each movement. Russia will likely answer with stronger jamming, smoke, decoys, wider spacing, counter-drone teams, and faster recovery units. Ukraine will likely push further with fiber-optic FPV, drone-laid mines, stronger reconnaissance networks, and deeper strikes against radar, air defense, logistics hubs, and command posts. The next battles may not be decided only by who has more tanks. They may be decided by who sees first, reacts faster, and keeps the kill chain working under pressure. War is not only measured by destroyed vehicles or shifting front lines. It is also a lesson about how technology, decisions, and human lives are connected on every battlefield. Understanding these battles matters because it helps us see the real cost of war and why peace should never be treated as something simple or guaranteed. If this analysis helped you understand the changing face of modern warfare, make sure to like, share, and subscribe to Military Force for more clear reporting on weapons, battles, and the geopolitical shocks shaping our world.